Hi everyone, welcome to Control System Lectures. In the last session, we had a brief discussion about describing function method used for the analysis of nonlinear system. In this lecture, we are going to discuss about phase plane method. Before going into that, first we will discuss about what is a phase plane. Okay, so phase plane method of analysis is a graphical method for the analysis of linear and nonlinear system. So the analysis is carried out by constructing phase trajectories. We will discuss what is phase trajectories in the later session. It gives about an idea of transient behavior and stability of the system. So usually phase plane analysis is restricted to second order system. Okay, so here you can see that a general second order system differential equation is given as d square x by dt square plus 2 theta omega n dx by dt plus omega n square x equal to 0. So this is a second order differential equation. So here we are taking x as one of the state variable. So we have already discussed the concept of state variables, okay, in last modules. So here you can see that we are taking x as one of the state variable, and theta you know what that is, that is a damping ratio, and omega n is the natural frequency of oscillation. Okay, so you are converting this equation to state equation model. That means we are taking x as x1, right? X as x1. So x1 dot equal to x2 and x2 is equal to x1 dot. So dx by dt. So dx by dt equal to x2. So you substitute that in this equation. So you will get x2 dot, x2 is dx by dt. So d square x by dt square means you have to differentiate one more. So if you differentiate dx by dt, you will get d square x by dt square. So you will get x2 dot. So x2 dot plus 2 theta omega n x2 plus omega n square x1 equal to 0. So the state equations are x1 dot equal to x2 and x2 dot is this equation, right? Minus 2 theta omega n x2 minus omega n square x1. So you got the state equations x1 dot and x2 dot. Okay. So for linear system, the state equations are a set of first order linear differential equation. And if you want to find out the solution of state equation, can be easily found out by simply integrating these equations. But if we have a nonlinear system, the state equations are first order nonlinear differential equation. So for solving the nonlinear differential equation will not be an easy task. For solving this nonlinear differential equation, we are using phase plane method of analysis. Okay, so for solving nonlinear differential equation, we are using phase plane method. So next we will discuss what is a phase plane. Okay. So here you can see that. So what is a phase plane? So it's a coordinate plane with the state variables x1 and x2 as two axes is called a phase plane. That means it's a plane in which the x1 axis is represented, x-axis is represented as x1 and the y-axis is represented as x2. It's a coordinate plane with state variables x1 and x2 as two axes is called a phase plane. In phase plane, x1 is represented in x-axis and x2 is represented in y-axis. Okay, and so suppose this is a phase plane. Suppose this is a phase plane and here you can see that x-axis is represented as x1 and x2 is represented in y-axis. So this is a phase plane. What is phase trajectory? So phase trajectory means the curve describing the state point x1 x2 in the phase plane with time as running parameter is called phase trajectory. Okay, it's the locus of state point x1 and x2 in phase plane is called phase trajectory. So if you find out x1 x2 point, the value of x1 and x2 at each point with the running parameter t, it's called phase trajectory. It's the locus of x1 x2 in phase plane is called phase trajectory. So this is a phase trajectory of x1 x2. Okay, so for each initial condition you can draw one phase trajectory. Okay, so the locus of x1 x2 is called phase trajectory. The plane in which x-axis is represented as x1 and y-axis is represented as x2 is called phase plane. So you got two terms, phase plane and phase trajectory. Okay, a trajectory can be constructed in phase plane for each initial condition. For each initial condition, you can draw one phase trajectory. So hence, a family of phase trajectory can be constructed. So this is the family of phase trajectory. So a family of phase trajectories can be constructed for a system in phase plane, and such a family of phase trajectory is called a phase portrait. Okay, so each phase trajectory is drawn for each initial condition, and hence you will get a family of phase trajectory. So a typical phase trajectory for a second order system. This is a typical phase trajectory for a second order system for theta equal to 0. Okay, so you have here one equation. So here you have one equation. If you draw the phase trajectory for a typical second order system with the theta equal to 0, you will get the phase trajectory as this. And if this is one phase trajectory, and if you vary the theta value, the shape of phase trajectory will vary. This is for theta is from 0 to 1. You will get one phase trajectory. And if theta is greater than 1, you will get one phase trajectory. Okay, so if you vary the theta value, you will get phase trajectories. And if you draw, this is the phase portrait for a critically damped system. Okay, so this theta is constant, but if you draw phase trajectory for each initial conditions, you will get a lot of phase trajectories, and the family of phase trajectory is called a phase portrait. Hope you understand this. Thank you.